Hi everyone! I will show you in this video how to draw a truss and make a static analysis on each member. There will be just one analysis, but you will have the information for the force inside each member. So first, open SolidWorks, create a new part. I just opened a new part, and I just add the picture of the truss that I want to draw and the different dimensions. So let's do that. I like to first save. So don't forget to save your part. Oops. Here we go. You can write the two dimension that we will use. So if you look on the truss, we will have a length and we will have 8. Everything else of the dimension geometry depends on just the length and the age. So let's go on Tools, Equation, and let's create those two parameters. So I will do a parameter length, and the length is 10. I will have to change the unit after. And the 8, in this case, will be, we will use 4. Okay. Speaking about units, let's change our units. That will be meter. So go on bottom and change it for meter, kilograms, and second. We can also add the material. So click right, edit materials, and we will use the ASTM A36. Let me check that. This is what I suggest, correct. So let's apply and close. Okay, so for the sketch, I will do the sketch in the front plane. So I click on the front plane and sketch and create a new sketch. Okay. I will use only lines. I like to center my truss on the origin. So we'll have the origin at the center, bottom center. Oops. Okay, first, let's begin to put the dimension on that. I don't need these dimensions. I don't need these dimensions. I need this one. That will be 10 meters. Oh, not 10 meters, sorry. Equal, so you click right. Equal, global variable, the length. Enter. You absolutely need to, I didn't take it. Oh, here we go, you take it. So the equal with the length inside, when it's correctly selected, you will have the sum sign in the front, super important. And the second dimension that we have was the vertical distance, that is the 8. So let's use a line, but define it at construction between this one and the origin. This is already vertical. Let's check, is it vertical? Oops. You can click on it and see. This is already vertical, so perfect. And you double click, equal, global variables, and you select the 8 and enter. Here we go. So this is blue. Why this is blue? You want it black, probably because it's not center. Let's check. Yes, I can move those points. So I will select this line and the origin with control and say that they are midpoint. Okay. And I lost my little picture, but the other information was we have a line from this one to this one and a vertical one. There we go. And same thing on the other side. I will remove the dimensions. I can remove the add dimension there. That will be faster. Here we go. Yeah, I don't like that at the dimension by itself. So what do we have? The dimension of this vertical member is half. It's an 8 divided by 2. Oops, here we go. And same thing for this one. Equal the 8 divided by 2. Or you can select the other dimension. Enter. Make sure that you have the sum sign in front of each of your dimensions, Oh, we got this point needs to be coincident with this line. Here we go. What we are missing too, that's the vertical one there. And that should be black. Here we go. So check that everything is black when it's black. It's fully constraints, cannot move anymore. Let's get out this sketch. Okay, so that was my first step. I made the sketch of the truss. Make sure that you save time to time. That was the step number 1. Now I need to create the weldments. Okay, the weldments that will mean that we apply a profile to each line of the sketch. And you have the weldments tab there. If you don't see it, click right, toolbars, and go select the weldment there. Maybe it's hidden. So you will create structural member. Let's use the first one, ISO pipe 33.7 times 4. So that means that your truss will be, a section of the truss will be a pipe of 33.7 millimeter. The diameter will be 33.7 millimeter, and the thickness will be 4. 33.7 is the outside diameter. Okay, and we will create a new group, and we will select, I select first the line outside. Oops. This is correct. You want to apply this corner constraint. Create another group. I select those. Did I forget a line in the middle? I forget a line in the middle. Can I select this one? No. Yeah, I need to add this one. So let me do this and this 4. Enter. And did you see what I'm missing in the sketch? I'm missing this vertical line. So let's go back on this one. Edit sketch. And here we go. Or you can change it for constructions to real element. So let me edit the feature pipe, and new group, I will add this one. Here we go. So now I have all my members that are a pipe. They are welded. That doesn't matter for the analysis because we will add joint after that. Let's make a save. Sorry for the missing line at the beginning. I use a construction line. I could use right away a full line. Okay, now we will begin the study. So you will need to go on simulation. Again, if you don't have the simulation tab, click right, toolbar, and go find the simulation. Where is this one? Here we go, it's there. So you will select new study. Let's open that a little bit. And yes, we will do a static study. Enter. So now you should have a new tab on the bottom that says static. And we will need to go through all the steps one by one. Cut list. You see we have the pipe. Let's check. So what I want you to check there, I want you to check that you have the material apply. Okay. Sometimes you have it right away. If not, you click apply material and apply. Okay, on all your pipes. So check, and you can select all of them. If you click there, that will apply all of them. If you click right, you can also apply the material on a specific pipe. Okay, it could be, you could have different materials if you want. Oops. So you just check that you have the material. Joint group. We will create joint where we have pin connection or a normal contact or a pin connection with the ground. Let me try to get my picture again inside the part. I don't know why I was able to get it first, but okay, I will keep it on the background and refer on it sometimes. So we will have a joint, a normal contact on the left, a pin connection on the right, and we will have pin connections everywhere where the member, where 2 members connect, 2 or more members connect, 3 members. So joint group, and I double click on them. Okay. And you check that you have the joint at each member. You see it did it well. You can click enter. You will recalculate the joint. That's fine. As soon as you see now the purple dots that are the joints, you will be good. Connection, you don't need to do anything. we will go to the fixture. So I double click on the fixture, or you can click on the advisor fixture on the top. Let me see, does that happen something on the right? Oh no, I click on the right, sorry, fixture advisor, or the fixture advisor on the right, on the top. Let's open here. You will have the simulation advisor that open to the right, and I will create add a fixture. So I want to create a fixture on the bottom left first. So I will select use a reference geometry, and I will use my front plane. So I will use the front plane as geometry. That means that the X and Y axis will be in the front plane, and the Z will be normal to the front plane. I want to add a fixture to the bottom left joint. And the geometry, that's this one where I need to click front plane. Here we go. So I am on the joints, bottom left, and front plane. Here, this is the freedom that you will apply and which translations and rotation you will block. So this is a normal contact on the bottom left. So you want to leave free the translation on X, like this. Sorry. It cannot move on the Z, cannot move on the Y, but it can slide on the X axis. So you click on the along plane direction 1, and you leave it this one gray, mean that it's free, and you block the two other one. Okay, so I explain here. The gray means that it's free. The 0 with the white background means that the translation is blocked. For the rotation, we want to leave the rotation about the axis Z, and we want to block the two other one. So white, white, and gray. Okay, so again, what does that mean? That means that the X translation is free, and the Z rotation is free. Okay, that's what you want for this joint. This is the normal contact. Enter. Okay. Now you can see that you have one first joint fixture at the joint, and you block the rotation, the translation on Y and Z, and you block the rotation on X and Y. Now you want to create more interaction. You add another support and fixture, add a fixture, and we will do it on that joint. We want to use a reference geometry, always the front plane. Let's click there, front plane. And for this one, it's a pin connection. So now it can rotate about the axis, Z, but it cannot translate on the x-axis. So it should be 0, 0, 0. We want to block all the translation at that point, and we want to block the rotation, X and Y, but we want to leave free the rotation on Z. So this one at that point can only rotate about the Z-axis. That would be the same axis than my referential there. Okay, and now we want to add pin connections at all the different joints inside. So you click create more interactions, add a support fixture, and we will use a reference geometry. I can click in that box and select my front plane. Can I do it now? Yes. And now we ask for the joint. So I will select all the joint. 1, 2, 3, 4, 5. Did I get the number 5? 5 and 6. Let me check. 1, 2, 3, 4, 5, and 6. And those, they will be free to move on X and Y, but not Z. Okay, so they are free to slide. They will slide a little bit, but you don't want them to go outside the plane. So you block the Z translation. And for the rotations, you don't want that to translate on X, on Y, but you want to leave it free on Z. So you can rotate on Z. Basically, what you don't want is that you don't want that your truss is going outside the front plane. Okay, you don't want it like to go outside my screen. You want to stay in that plane. And you can click enter. Okay. So we did the fixture. Now we need to apply the load. So if we look at the load, we have a F1, F2, and F3. And oh, I cut it there. But I propose to put 2 kilonewton, 3 kilonewton, and 1 kilonewton. So let's do that. So create more interactions. And now you can click add a load. Okay, you click on the bottom, add a load. We will add a load on the joint, so click on the joint selection there. First one, we will use the front plane again as reference. So we want to apply a load on the Y. So this one, and we want to apply 2000 Newton. You see the arrow there? It's going up. Click reverse directions, it will go down. Enter. Create more interaction, add a load, add a load. We will select the join, the one in the middle. We will use the front plane as reference. That will be on the Y. That will be 3000 Newton. It's going up right now, so let's make it down, enter. And one more interaction. Add a load, add a load. We'll select the join, this one. We will select the front plane as reference, and we will apply 1000, sorry. Keep the same number than in my PDF. Reverse directions to go down. You can see the 1, 2, 3 loads that are applied. And you can check there the loads too. They are both, the 3 of them are on direction number 2, so that's on the direction Y, because the front plane is in the X and Y axis. We are almost there. Done. Continue to next advisor. We don't want to change any settings. Let's do run the study. I think that will mesh by itself. Oops, we'll create my mesh. Here we go, perfect. Okay, so that's look a little bit crazy if you click. Let's move that. Check deformations is a good start. Oh, let's read what they say on the right. Check the deformation. The deformation is 0.001 meter, so 1 millimeter. That's good. What is if I do stop there? Oh, I may have not done that. Okay, so I will check. You see, the first thing that you can check there is the deformation scale. It's a lot. Time 946. So that means that it's much more than what you see there. It will be much smaller than that. Okay. So if you want to change that, what you can do is you can click right on the stress, edit definition, and there you can change the deformed shape, user define, and select 1, and click enter. And do you need to I maybe need to restart that. Let's look at the deformation there. Let me check something. If I change my deformation scale, definition, user scale, 1, apply. Here we go. It's back to the correct scale. So we see it doesn't move, almost not. And you can see which one is where it is red, so it's moving more there and more on that side. And you should not move at all at that point because we blocked that point. Remember, we just have the rotation. It's blue. That's correct. It's almost 0. So the deformation looks great. Let's click on the stresses. What we can see there is the stress in the different components. And what we want is we want the same stress in this member from the beginning to the end. Remember, if we cut at any spot on this one, it will be the same. This one is the same color all the way, same color, and it's almost blue. Why this one are almost blue? Look at both sides, it's almost blue. Does that make sense for you? I'll let you think about that. And I want to show you something. You can click right, edit definitions, and you can select, instead of the axial and bending, you can click axial only. It will be almost the same because in the truss, we have only compression or tractions in each member, but that will make a little bit more sense to have the axial. Okay. You can add, if you click plot tools there and probe, it's cool. You can click, for example, there. Oops. I will have the value of this specific member because it's a bit hard to see with the scale. So we can see this one, can see this one, you can see different one, and you can compare them. I want to show you something. This one, -4. Oh, that's so that's something. It's stresses. It means it's Newton per millimeter square. So it's dependent of the section. If you want to know the axial load, not the stress, the axial load, there's a way to do that with the report. I will show you. Oops, let me make that. Because right now, what you have, the information that you have with the probe, the stress, you need to multiply them by the sections to have the load. But if you do reports, you can have everything. Let's publish that. I don't change anything, but you can if you want. That will create a report with all your data. So the load that you apply, the truss, the material, and also give you the load inside. I will show you where is this information. It takes a little bit time to create the reports because they will add some pictures, add the colors of the deformations and the stress, everything that you may need after. Almost there. I know you can skip the video a few seconds. Here we go. And the report that we get is a Word document. So it's super convenient because you can add descriptions, say title of your project, what did you assume, that's only pin connections between the members, the materials, etc., etc. You have the information for the the truss. If I will have zoom a little bit more, I will see it a little bit bigger instead. It's hard to see there, but you can see which pipe is which one. I will show you on the graph on SolidWorks after that. What I want to show you, if you scroll down, you have a lot of informations, the reaction force. So we put 2,000 plus 2,000 plus 1,000, tell you the total is this one. The moment, we didn't put any moment. The table that I want you to look at is this one. Where's my let me see. Try to zoom on that one. I lost my zoom there. It's below my toolbar. That's okay. So this one, axial load, this is the load in each beam. For example, the beam number 7 will have an axial load of 1.8. Be careful because there is point and there is comma. And the beam number 8, we will have a load of 1,500. Okay, so 1.5 kilonewton or 1,500 kilonewton. Where are those number 8 and number 7 and number 8? If you go back on the beam and you go back on your sketch there, up, you can see in the pipe, those one, let me check. This one, for example, we were on number 8. Number 8 is this one on the middle. Let's check this data, number 7. You see this number 7? That this beam, what we get in the report, we got for number 7 something very close to 0. You remember that was the vertical beam that was blue. Why? Because those two beams are zero force member. Those two members are zero force members. Because at that point, there is no external load, and we have 3 beams. Those two are collinear, so this one must be 0. So number 7, that's why we get an answer close to 0. You see number 1, number 2, for example, number 2 has 1, 2, 3, 4 segments. So in the report, if we look at number 2 is this one. We have 1, 2, 3, we have 4 different values because that's for each segment. So number 1, number 2, number 3, number 4, that's the 4 segments of this beam. So there, what is super important is this axial column, and again, you will have the data that will be the same data that you will find with your calculation by hand. yeah, you have a few more informations. You have the picture there. Again, if I will have zoom, I will have see them a little bit bigger. You can write the conclusions there. This one at the same data, but this one are the stresses. You see, Newton per meter square. I want to show you one thing, and all the bendings, torsional, all of that should be very close to zero. Let's look at them, very close to zero. 10 power minus 20, almost zero, moment almost zero, because we know in the member, we assume that we have only compression and tension. I want to show you one more thing that it could be useful. Let me go back on that. Can I edit my sketch? How can I just want to, can I add that? There we go. I try to, yeah, I don't want to delete it. Anyway, I will keep that. But something that I found useful is you have your sketch, and what you can do with your sketch, if you can check your dimensions and your geometry that you find by hand. So let's say you want to find the angle between those two. You can go on the evaluate, sorry, and the measuring tools, and you can measure between this one and this one, and you will have the length. Let me do the not center to center, or not. Let me see. We have the distance there. I want the angle. I'm always lost with this one. I don't want the distance. Okay, maybe you know. Long time I didn't use that. So you want to find the angle there. If you cannot find it this way, another way would be to do a drawing. So you can just do very fast, make a drawing from parts. I know it's one more step. That doesn't matter. Oops, I will use the font. Put it there. Oops, here we go. Let's just do that. And now I can make my dimension. Here we go. I have my angle 38.66 degrees. So you may want to check your dimension like this. I know it's not the sketch, so it's a bit harder to think which dimension do you take. You can see the joint. That's interesting. That's how the weldments made the truss and the connections. But that's another way to use SolidWorks to check your truss analysis. So yeah, that's it. Where's my truss? Hope you like it. When you save your truss and everything, you will have the statics analysis that is saved. That will create a lot of documents in the folder. You will also have your report saved in the same folder where you work. And you can edit this document to add more information if you want. You see, before you start the analysis, make sure your truss is center and zoom enough. So after that, it takes more space on each picture. Hope you like these little demonstrations and have fun with all your truss analysis. Bye-bye.